All right, so we're looking at problems 81 to 106, I believe, in preparation for test tomorrow. A little practice. Yeah, practice, a little repetition of topics. That's how you're going to get recall. You got to keep doing things a lot in order to bring it into your next class. So I'm looking for the tangent to the y-intercept, and I'm looking for the tangent to the point of inflection. And I'm not doing calculus here, but you can look at the playlist where I do completing the cube and putting cubics in graphic form. All right, so I have a negative cubic, which means if I put a really, really big number in, this is going to control n behavior, not these. You know, a billion cubes got a lot more decimal places to it or digit places to it than squaring a billion. So I know I'm going down on the right, I know I'm going down on the right, going up on the left, because if I put a negative big number in, 4 negatives make a positive. All right, the question is what's going on in the middle? So we're going to do a quick minus b over 3a to find the x value. So we got minus 12 over minus 6, so positive 2. So I know right here at positive 2, I've got a point of inflection. And I'm going to put it into the equation. So 8 times, so this is negative 16. So when I add this term, I'm going to get twice that and change the sign. So 32 minus 20 plus 5, I do believe is 17. So that's where I'm at, 2 comma 17. How about I just do the point of inflection, POI? Point of inflection is 217, and let's call that just this dot. You'll have to remember, all right, so that we can see what we're doing at that dot by c minus 3ah squared, and that's minus 10, minus 3, a is minus 2, 2 squared is 4, so it looks like I'm going up at minus 8, minus positive 24, minus 10, 24, minus 10, 14. So I'm going up at 14 to 1. So that's doing that. So it looks like I've got something like this. All right. And let's hope I didn't make any errors. Let's just double check this. So minus 16. And if I put 2 in there, I got 4 times 12, which is 48. 48 minus 16. Okay, I'm happy with what I wrote. All right. So what is the tangent? Because that's what I asked. The tangent is 14 times x minus 2 plus 17. That's what I want you to learn how to do. And I hope that looks kind of linear right there. Right? And if we want to find these, we can get them quickly, but at least get the tangent. The tangent to the y-intercept is, in a polynomial, the last 2 terms, always. So minus 10x plus 5 at 0, so 0 is over here. So that must be my tangent line right here at 0, 5. You can see 0, 5, so y equals minus, we might as well leave it just in that form. That's going to be there. So this x value is going to get measured from 2, and I know I'm going back. It's the square root of minus 14 divided by 3 times a. That's negative 6. So it's, yeah, it's real. We have a real local minimum. Yeah. And it's to the right of 0, I think, because that looks to be about 612 to a little bit more than the square root of 2. Right? And the square root of 2 is approximately 1.41. So it is a positive number, so it's to the right of 0. This is the 0, and it's probably not very far. So it's probably, you know, in terms of scaling, I'm not doing any scaling here, but those are things I can pick up quickly. And so that x value should be 2 plus the square root of 14 over 6. And yeah, I don't care if you reduce the fraction. We're talking concepts here. All right. I hope I didn't make a careless error there. If I did, write it in the comments and we'll amend it on the next video. All right, Renee, let's go for a roll. Renee the cart is going for a roll. There we go. I got a nice science card here in honor of Rene Descartes. Y-intercept for this function. Well, that means I got to plug 0 in, right? And then we're looking at 4 times e to the ln of 7. I don't think you know the ln of 7, but I do think you know the ln of 2. That should have memorized that. So why don't you think of this one first? What is e to the ln of 2? I bet you know that. I bet you know that the ln of 2 is 0.7. I think you're very familiar with that. And e to the 0.7 is 2. Oh boy. So ln of 2, that became 2. I started with a 2. I ended with a 2. I think those are inverse operations. I get 4 times 2 is 8 plus 5 is 13. I bet you can do that one now. You should get 4 times 7 plus 5, 33. All right, points of intersection. I think I asked for x-intercepts. Well, boy, did I butcher that worksheet today. All right, I didn't really look at it, and I didn't even look at the answer key, and I attached an answer key to a different worksheet. That answer key is not helping you. All right, but hopefully this video will. So let's find the intersection. Intersection of two curves is when they equal each other. I said you should always look at this and know one of the intersections is 0. So if I put 0 in, I get 0, 0, right? X squared, and 5x, right? So that works. And then I think you can get rid of one of the x's, and I think the other one is 5. And 5 squared is 25. And 5 times 5 is 25. Now, why is that a skill that you need? Because in a calculus class, you're going to have to sketch these. Y equals 5x, and you're going to have to find that 0, 0, and that 5, 5, because you're going to be asked to find the area underneath, the area bounded by these curves in terms of x and in terms of y. And the calculus teacher doesn't want to have to spend time finding the intersecting points or showing you the graphs. Because if you're at that level, you're supposed to know how to do it. I'm trying to make sure you do. So that one's done. Ouch. Oh, this is the one that I missed. This is the one. That was fine. Directions for that were fine. This is the one I wanted x-intercepts, and that makes no sense. All right, so let's just do what we did in the last problem. How about you sketch that and find the points of intersection? And I'm just going to do it. Well, if you don't know what that is, you got to put numbers in, like 1 gets you -1, 2 gets you -2, 3 gets you -3. I think I'm looking at y equals -x, which is decreasing at 1 to 1. I think I've got x squared, which is that cup-shaped graph, and I'm moving it down 20 units. I think that's what I'm looking at. So how do I find this value and how do I find that value? The same way we did before. We set it to 0. Well, I never really set it to 0. So x squared plus x minus 20. You ought to get in the habit of setting your quadratics to 0. Sometimes you don't have to, right? But a lot of times setting it to 0 and factoring is the easiest way to get a solution. And I think we can see pretty quickly that we have solutions at let's see, this one is here. So this is smaller number. So that's going to be the 4. And if I put 4 in, I get -4 out. And if I put 4 in here, I get -4 out. So this one is -5. And I bet I get 5 out. Appears to be true. All right, f of 2x minus 3, and here's f of x. So have a go at it. I hope you also know on your SATs, it's going to be written that way. So what is the f function? The f function takes the number 4, multiplies it times something, and adds 7. And I think the first thing I'm going to do is f of 2x minus 3. I think that's my input. That's 8x minus 12 plus 7 is -5. I got a new input because I just did this. And now I have to do what I get as an input, 8x minus 5. So how do I do that? I come back to the original. I multiply my inputs by 4 and then add 7. Sure looks like I'm getting, for an answer, 32x minus 20 plus 7 is -13. That's how you do that. Did you see that? Barely. I got to keep an eye on the camera better. But I'm so close here. These desks, let's move them. Come on, Rennie, let's double park here. There we go. The ln of 15. I like you to know ln and e to the x values. All right, and my class does know those now. So the ln of 15 is going to be the ln of 3 plus the ln of 5, and I want to show you where that comes from. And that's 1.1, and that's approximately 1.6. So approximately, I didn't use an approximation sign. Well, that's equal, but approximately 2.7. So 2.71, which is an approximation for E, and that's what we're looking for, exponents on top of E. If I put that exponent on top of this base, I'm approximately getting 15. You go try it on Google. I think we're off by a couple of hundredths of a decimal place, but not bad, and we get a feel for some numbers. So if I was graphing the ln of 15, doesn't hurt to graph that really quick. And over here, a 1 gets me 0 because e to the 0 is 1. Then over here at 2.7, 1, 2.7, maybe there, my altitude, my y value is going to be about 2.7. And so if I ever wanted to write, not that I care to write it this way, but if I ever wanted to write 15 to the x, that exponential function, it's approximately e to the 2.7x, which means I can write any exponential function provided I have the ln button on a calculator. All right, so that's that discussion. Righty. Let's make some space here. All right, so sine function. You're getting pretty good at the range. Most everybody has that, I think, except for the folks who aren't looking at the videos. 11, 16, and 6. I think those numbers speak for themselves. All right, and the sine function measures height, and we're going to walk around the circumference of the circle, and we're going to take 6.28 steps to get back to there. But we start here, and I think every trip starts with 0 steps. Okay, so that's 0 is the same thing as 0 degrees, and I cannot draw the triangle. The first one I can draw is a 30-degree triangle, and that height right there is a half. The next one's 45, and that height is root 2 over 2. Maybe I even write it as root 1 over 2, root 2 over 2. 60 degrees is root 3 over 2, 0.87, right? And 90 degrees is 1. Looks like I'm starting in the middle and going up. I'll come back down and come back up again. So that's one period of the sine function. Okay? Now, if you walk around the circle at a certain rate, you're going to get something that looks like that. If I walk around like I'm going to get something that looks like this. And those have periods. This period was 6.28 steps, 6.28 steps, and my period of the function right there, that length is going to be a 4, a 0, and a 19 if I did that. No, I didn't do that right. So 60 and 24, 84. All right, there we go, and that's still 18. Yeah, I wonder how that compares to that. I think it's a 3-to-1 ratio. Yeah, I think this is 3 times longer than that. Now, why is that? Come back to look at this. And you look at division by 3. Think about that. Think about g of x takes 1 hour to complete a task. 1 hour. What's it going to take to get that 1 now? It's not a great analogy. If you're going around the track at a certain rate, and I'm going at 1/3 the speed, because I could have written this as 1/3 x minus 5/3. I could have put it in factored form. That 1/3 means it's controlling rate. Right? If I tell you got to pay $30 to get something out of a store, you got $30, right? And I tell you, well, how do I want to say this? So it takes $30 to get whatever you're trying to buy. that box. Then what's it going to take if it's x over 3 to get that box? Well, that's got to become 30, which means that number's got to be 90. There, it's late day. Not sure I'm saying things as well as I could, but that dictates the rate. So let's go back to x minus 5. Let's put some numbers in, right? We start our walk around the circumference at 0. We finish at 2 pi. So I want the sine of 0, and I want the sine of 2 pi. And these are angles. Those are angles. So this is all about angles. What makes 0? 5. So my period is going to be to the right of 5, 5 plus something. So let's solve. X minus 5 over 3 equals 2 pi. It's 2 pi over, that's once around a unit circle. So I've got to move the 5. And I've got to multiply by 3. So x minus 5 equals 6 pi. And I'll move the 5. 5 plus 6 pi. That's 3 times the normal circumference around a unit circle. So that goes there. That gives me that value, 11. This one is still 11. And now I've got a lot of symmetry. So 5 over 5 plus 3 pi should get me 11. And 5 plus 3 pi over 2 should get me 16. That's worth doing. 5 plus, can I squeeze this here? 3 pi over 2. Well, what happens to the 5s? 5 minus 5 cancels. Dividing by 3 gets rid of the 3s. And now I'm at pi over 2. Pi over 2 is right there, which is 1, which happens to be a maximum height. And I'm at a maximum location. 1 times 5 is 5 plus 11, 16. That's a coordinate. Angle to ratios. And the ratios are getting multiplied and adjusted. All right, so name this tune. I haven't put any ellipses in factored in standard form or in graphing form, but I hope you have some intuitive sense. You pause the video and see if you can figure out what the center is, because that's where we're measuring from. Okay. Well, it doesn't appear that the altitudes are changing, but I went from 0 to 8, so that center is at 4. -1 to 5, what's between -1 to 5? 2. That's there. And it looks like from 4 to 8, that's over 4 units. And from 2 to -1, that's 3 units. It's got a little wobble to it. So see if this makes sense. In a circle, if I did x minus 4 squared plus y minus 2 squared equals 25, for instance. All right, you get a feel for that. Radius of 5. But I also could have shown it this way. All I did was divide everything by 25. Well, all I'm doing here is, that's called the major axis, and that's an x, that's horizontal. So that's going to be 16. And this is 3, that's the minor axis. That's going to be 9. And that's the graphing form for an ellipse. I don't think we have enough time in the semester for me to start putting those. I might do one for you, but I don't think I'll test you on it. I think learning e to the x, ln of x, and getting a good start on the unit circle is far more important. But I will show you where those come from. All right, but that's what that one was. And I hope that makes some sense. Minor axis, major axis. Okay. Let's get rid of that. So name that tune. Now we can fly. We're real familiar with this. X minus 3 squared plus 30. That's no problem. How do you get from 30 to 7? Down 23. What's the square change in x? 9. X's have changed from 3 to 0, but I'm looking at squaring. And this is where change is. And this is not the change. That's the variable change. Changing the change by squaring it. So that's 9 units. So let's see why 0 gets us 7. Put 0, and you'll know why I did that. Plug 0 in, do the math. Minus 23 ninths. 0 minus 3 squared is 9, plus 30. You do the math, and I think you'll see 0 gets you 7. Okay, so that one's done. Okay, we don't need to talk about, y equals 5. I'll do that. All right. So I'm hoping you can get the base of this exponential function quickly. All right, that's a prompt. I'm saying that because I'm hoping your brain does what? You pause the video, and then I'm going to do what I hope your brain does. Hope your brain figures out that distance. It's called the differential. And I think that difference is 26. I think the next differential, not drawn well. Oh, see, I'd move this so that we could see the differentials. I'm going to move that differential. That's 13. I wonder what the base of the function is. I think it's the ratio 13 over 26. And I think 1907, I'll put x minus 1907. And I think I'll put 2000 in here. So you put 1907 in there. 1907 minus 1907 gets me 1/3 to the zero. On 1/2, excuse me. 1/2 to the zero, which I think is the number 1. I think I can multiply that times something plus 5. I think I can do that to get 31. I think I can do that. Oh yeah, it's 26. Yeah. And then let's put 2000. Gosh, sorry. 1907 to 2000. Major mistake on my part. I hope you caught it. What's that? 93. I seek forgiveness. Okay. So now drop 2000. That input. I think I get 93 divided by 93, which is 1/2 to the 1, which is 1/2. I think I can figure out what that multiplier is if I want to end up at 18. Yeah, I think I need, I'm losing train of thought here. Sorry. So that's 1/2 of 26, 13, right? 13. Oh, okay. So yeah, so that's, well, it gets the number we want. All right, so that's the function, plus 5. I should have put that there. All right, so put the numbers in, you'll see you get what you want. All right, yeah, I'm getting a little daffy here. I've been doing math since 5 o'clock, haven't stopped. And now, what's this logarithm? It's got a base. I wonder if you can get the base quickly. That would be helpful. It would be conceptually helpful. Well, the inverse of exponentiating is logging, and the inverse of vertical is horizontal. From 4 to 9, that's 5 units. From 4 to 19 is 15 units. I think the next one, I'm going to go up 50. I think I'm going to get 2100 out when I drop in 45. Well, I need 45. So 45 is tripling. It should have been the same. I can't reach much higher. That distance and that distance should have been the same. So let's see. Boom. Here, 45. Now, that's going to take a long time. That's going to take a long time to get out that far, right? But I got a feeling 45 and 4 is going to be a friendly number. We'll check it out later. And if it's wrong, I'm not making the video again. We're going to go with what I got here because I'm just getting a little squirrely. All right, so I think the derivative, I think the base is going to be a 15 over 5 base. All right, so what do I start with? I start with a y. Why don't I start with x equals 4 over here? Let's start with y equals the y I see, 2000. What do I want to get? 2050. I better add 50 because I'm trying to get 2000 plus 50 times 0, and I'm trying to get 2000 plus 50 times 1. In fact, I'm doing that with every one of these calculations for the most part, till we get to the rational functions. I'm setting up a template here. Now, when does a logarithm equal 0? I used to run silent practices in soccer once in a while. So to get those fellows calling for the ball to be quiet so that the person with the ball could decide what to do with it without feeling like 20 people are yelling. All right. So That was a silent moment. Hope you filled it in with a 1. Oh, I got to make a 1. Well, first off, 4 is a domain restriction. So I drop in a 9, 9 minus 4. I think I got to put a 5 there. And I think that 5, we're seeing it here. I don't think that's a coincidence. And I think when I drop the number 19 in, 19 more minus 4 is 15 divided by 5. I think understanding logarithms is really all about understanding these differentials. And I got a feeling that if I pick 49, it's going to be nice. Let's find out if it's nice. 49 minus 4. 45 divided by 5 is 9. 15 divided by 5 is 3. What's the exponent you put on top of a 3 to get a 9? I think I'm going to double 50, which is 100. My God, there's a pattern here. It's nice to see patterns. Okay, 7x minus 2y equals 28, so I know it's going up. If I put a 0 in, negative 14, 0, negative 14. And if I put a 0 in here, I get 4. So 0 is smaller than 4, so 0 gets me negative 14. And if I put in another x value of 4, I get 28 equals 28, so 4 when I put a 0 in. So yeah, we work with zeros. There's that line. If you're doing something else, changing it to mx plus b, you're working way too hard because this is a graphing form called standard. When you have a graphing form, that means you don't have to do anything. Just graph it. Cup shape up. Minus 20x plus 3 is the tangent to the y-intercept, so it's on this side. Minus b over 2a, 5. It had to be positive. 5 to the right is 0. Plug a 5 in. You got minus 100. Cut it in half. Add 3, and you got yourself negative 47, and you're done. You also have your roots. Your roots are measured from 5. Plus or minus the square root. I got to go up 47 units to get to 0, but I'm multiplying by 2. And there's your roots. And Rene, you're a little off-centered there, Rene. And I forgot to do that. Minus b, minus 20 becomes positive 20 divided by 4. That's where that came from. Drop a 5 in, and you can see that that's 50 minus 100. That's why I took the shortcut and cut that in half. 50 minus 100 minus 50. That happens every single time at the vertex. All right, so I standardized my e to the x graphs. I standardized them. I make a jump, a 3-to-1 ratio jump. 3-to-1. I always do that. It's not hard to find the asymptote, y equals 4. It's not hard to take the first jump at 3 and then the next jump at 12. And then I know that I've got 4 plus 12 is 16. It's going to come out of that. 4 plus 3 is 7. It's going to come out of that. All I got to do is find the right answers. And I think the way I get 7 is to say 3 times 1 plus 4. So it sure would be nice if I knew how to put an exponent on top of e to get 1. Be nice if I could. Oh yeah, that's the number 0. Well, I guess I got to make that 0 in order to get 3 plus 4. Sure looks like a 5. Yeah, and it sure would be nice if I could multiply that by 3, which is not 12. I multiplied that. That's a 4-to-1. Why don't you yell out? Why don't you yell out, you goofball? All right, I want a 3-to-1 ratio. All right, sure would be nice if I knew e to the what got me 3. Well, that's why I had you memorize 1.1. It's pretty close. I know it's 1.09. A lot of stuff after. I'm just calling it 1.1 to get a feel. I think it's 5.5. You practice that 2 minutes a day for 4 or 5 days. You should own it as long as you see it every week, at least once for a month or two, because it's all about recall. If you can't recall what we're doing here, it's not going to be any good to you next year. Well, you'll review it, I hope. Might not do it that way, though. All right, so from what we learned before, I think I've got base E, but I'm going to make it a 3-to-1 ratio because I'm going to standardize it. And so I need the ln of 3 I wonder what that is. I wonder what the exponent is that you put on top of e to get 3. Oh yeah, we just said it. It's about 1.1. And I think I want the ln of 1. That's the exponent you put on top of e to get 1. I wonder what that is. Oh yeah, that's 0. That means I can do a little multiplication. Yeah, I think I can get away with that. I think I can multiply these numbers nicely. Yeah. All right, when's this undefined? When x is 3. And I want to get a 3-to-1 ratio. And let's see how we do that. Well, it's a little bit different than the exponential, but I'm definitely going to put a 4 in here. Because 4 minus 3 is 1, and the ln of 1 is 0, and 0 times 4 is 0. You know, I think I'm going to get that every single time. Every single time I multiply the ln of 1, and I add a constant, k for constant, I'm going to get k. So all I got to do is figure out how to make that parentheses 1. In fact, logs, you want to make the parentheses 0. That's going to be your domain restriction. You want it to be 1 because you're going to get the constant. And then you really want it to be the base, but ln is a little different. You're going to want the parentheses to be 3 because we know we get 1.1. So I think I want to pick a 6. Okay, so what were the two things I'm picking? A 4 and a 6. So I'm going to pick a 4 and I'm going to pick a 6. Okay, and let's see what we get for answers. All right. How far is 6 from 3? 3 units. But I want 1.1. See, I'm thinking about other logs right now. So I need 6.1 minus, no, I want 6. 6 minus 3 is 3. That's what I wanted. So that's 1.1. Here, 4.4 plus 5. 4.4 plus 5. I'm having a slow brain here. 9.4. Okay, I picked some easy numbers. And this was x minus 3. Right? Now when we put a 4 in, we get the ln of 1, which is 0. We're going to multiply that by 4, and we're going to add 5. I think we get 5. When it's another log, it just becomes 4 plus 5, 9. If it was a different log. Let's do a different log right now, base 2. Let's just do one because we're getting to the end of the term and we need more of these. So you try that one. I'm adding one right now. You pause the video. I'm just gonna knock it out. Let's make it base 5. Let's make it base 7. All right, now try it, base 7. All right, so no difference there, x equals 3. This is a 7-to-1 ratio, so I'm going to pick a 4 again. 4 minus 3, 1, that's going to get me 5. And then I'm going to pick a number 7, so I want 10, right? Because 10 minus 3, you want it to be the base. The argument, set the parentheses to the base, which in this case is 10, right? There's 7 units of differential. There's 1. So there's my 7-to-1 ratio. That's not so good. That's not so good. There we go. There we go. So that is what? That is 4 gets us 5. Notice the same thing in the last one too. And then this one is 10. Now gets me 4 plus 5 is 9. So there's the ln and the other logs are very similar. I just picked the ln of 3 instead of the log of the base. All right. If this was a base 5, very friendly number there. Easy to multiply by, easy to add a constant. That's why we're doing it. All right. Now let's talk about the period of this function. I know 3 pi for a sine function is 1 pi, 2 pi, 3 pi. 3 pi is there. Okay, so that's 180 degrees, another 180, another 180. But 2 pi is once around. And so I wonder what that is. 2 pi divided, because I do know 3 pi over 20. I think, if I'm not mistaken, that's 40 pi cross multiplication equals, I wish I picked an even number here for you the first time doing this. 3 pi n. Okay, so I'm going to divide by 3 pi. And so 40 divided by 3 13 and a third. It's going to take me 13 and a third units to get to here. All right, so let's pick some numbers here. I think, I don't know if I like what I just said, but 2024 kicks this off. I'm not drawing this. I'm not drawing this. Pi over 2. Pi over 2 is going to be here. And that's what we're going to be starting with here, because that's a max. Pi over 2 is there, right? And that's a height of 1. Starting from 0, this is pi. That's pi over 2. So at 90 degrees, the sine function is at a max. And I'm starting at a max when I put 2024 in. Okay, and so pi over 2 gets me 1. 1 times 7 is 7, plus 25 is 32. Now, I should have done that to begin with. I should have got my domain and range right away. Well, not domain right away, but range. Where am I? 25. And then 7 down. Right, that should look familiar. I shouldn't have to talk about that too much. We just figured that out. And now I'm going to go 20 units over to here. This is going to be 20 units over here. So that's going to be what? 20, 48. Took me a while. That should get me 18 units. So what's the period? That's the period right there. And I think I said that that was going to be 13 and 1/3 units. Okay, so that's, yeah, that looks about right. I didn't ask that on the worksheet, but I just thought I'd show it from a different perspective here. Okay. I could say more about that, but that's enough. We'll deal with that more in class later. Because I'm getting tired. All right, so we talked about that today in class. This is a fraction. All right, so what do? You put numbers in for x. Inputs, numbers. We're going to put numbers into this fraction, and we're going to get values out. Values of the fraction. That's what we're going to get, values of the fraction out. So what numbers do you want to put in? Well, I hope you're seeing plus and minus 3. And I could factor that. And we talked about that in class. Those are your undefined moments. I'm certainly going to put a 0 in there and get 4/9. I put a 0 in, definitely want to see that. I definitely want to put it in factored form so I can see sign changes. They're both to odd exponents, so sign changes. I'm going to go from positive to negative to positive, so on and so forth. And I think I'll put a really big number in and go back to x squared minus 9. Now let's put 1,000,000 in here. Minus 4 divided by 1,000,000 squared with subtracting 9. How about if I just put a number in like this? How about I really put a big number in and ask you, well, what's the value of that fraction? Pretty darn close to 0. Then I guess I have to ask, is it positive or negative? Looks negative. Looks like as I head to infinity, I'm getting close to 0. All right, so the next thing is x-intercepts. So when does that equal 0? I usually get students to say when x is 0, which is wrong. Right? Well, in this case, 3 or negative 3 doesn't get 0, gets undefined. And we can see that by this, that little calculation, I think is true, even if I move the 2 to the other side. So this calculation, I'll move x squared minus 9 to the other side. Yeah, 0 works all right. 0 times anything is negative 4. Yeah, no x-intercepts. We are not going to cross the x-axis. I cannot find the value of a fraction that gets me 0. Just not going to happen. You get zeros out of the numerator when you're dealing with fractions. So I'm not going to get any x-intercepts. So as I get closer and closer to 3, I can't cross the x-axis. I got a feeling I'm doing that. Now you could verify it by maybe putting a 4 in. 16 minus 9, minus 4/7. Okay. Yeah, a little further below the x-axis. And if you really want to see what's going on here, put 3.01 in there and square it. And you know what you get when you do that. You get 9.0601 minus 9. You get a number like that. How many times is that going to go into -4 with a decimal there? Well, that gets me 10. That gets me 100, 1,000, 10,000 times 6. I think you got -24 just from that part alone. And then you're going to get more zeros. I think you're heading to negative infinity. Whew, yeah, it looks like this is going down and down, negative infinity, the closer I get to 3. So what did I just ask you to do if I wanted to find that number? I hope you're saying the limit as x goes to 3 from the right of this function is equal to negative infinity, because I'm going to ask those questions over here. Where did I ask that one? I usually, oh, there, right? There's infinity. We go to infinity, but I didn't ask, I did it from, as x goes to infinity, well, that's a different question. That's what's happening over here, right? And I hope you can say, well, that's 0. Now we did this one, that's negative infinity. And when are we less than 0? Well, let's get the rest of the graph. Can't cross the x-axis, then it's got to do that. And if you want to see that, then come into 3 from the left and put a number like 2.9999999 minus, square it, minus 9. And you're going to get a positive answer, right? But I'm dividing it into a negative. I'm going to get a negative. Did I just mess up? Put a 0 in, 4/9, that's right. That's got to look like that. All right, so I went from negative to positive. I got to go to negative now. It's got to do that. Y equals 0. All right, I would love to put some more numbers in here just because I'm getting mentally tired. And when that happens, the gears stop working. I'm that old. All right, I think I've done justice to the cause. Now we can look at when is this less than or equal to 0. Well, these numbers certainly aren't. So those inputs don't work. They don't work because those are positive values. So I don't want those. I want these. So what do I have here? I have 3 to negative infinity. So negative infinity to 3. Union, that was a 3 to infinity. That's what we're hoping to practice for the last 3 weeks. Practice quite a bit so that we can see what's going on. All right, still got more to go here. All right, so what's this one look like? I'll put it in factored form now. X plus 3, x minus 3. I'm just going to do it without talking to you because I'm starting to really make mistakes. So I'm still seeing this. I didn't leave much room here. Let's do it over here. Make sure you can see this. Yep. So there's 3. There's -3. You can get plenty of practice just on the YouTube. Doesn't have to be my channel, any channel. Go to YouTube, graphing rational functions. You'll get problems like this. I see an x-intercept at 1, 0. So 1 gets me 0. I got a y-intercept that was x squared minus 9. Minus 1 over minus 9 is 1/9. So that's 1/9. I'm just going to leave that as your y-intercept. I can see that I have an x over x squared, which reduces to 1 over x. So that also goes to 0. When I put big numbers in, this exponent's bigger than that, so I get a over b. They're both 1. So I don't need a over b. It's that over that. It's going to give me definitely some kind of exponentiation power greater in the denominator. And I can see that I'm positive here, so it's got to be negative. And so if I put a number in like, where the heck am I? If I put a number x squared minus 9, let's go back to that. Boy, am I getting tired. All right, so if I put a number like 5 in, 5 minus 1 is 4, and therefore that's going to be 25 minus 9, so that's going to be 16. 4/16 is positive. So right here, so I think what's going on is I think I'm going to have to take more time and hope my brain reboots. should look like this. But I need a sign change at 3. Oh yeah, no, I'm not getting a sign change at 3. So I've got to go back to really doing some point-by-point analysis, and that's okay for you to see. My brain's tired. I've actually got to put some numbers in, like 10. All right, 10 minus 1 is 9/91. So that's a positive number, so that verifies that. That's what I thought. So over here, I still have this, but I think that's what I did wrong. I said 1/9 when I put a 0 in, and I put 1/9 below the x-axis. So my forgiveness here, so that's 1/9. There we go. Now we got it. Got to know when you're wrong, when you're doing something wrong. Sign changes all over the place. There, we finally got it. That's that graph. My apologies for getting a little tired here. All right, so put a 0 in. Put a 0 in. I had 1/9. I wrote it, but I put it in the wrong spot, and that caused all that trouble. All right, so that's that graph. Let me finish this thing because I'm starting to get squirrely. All right, so V shape up. 4 gets you 7. I know I got a 6-to-1 ratio going up and down 6-to-1 there. I hope you can see why. If you put a 0 in, I get 12 times 2, 24 plus 7, 31. 0 gets you 31. You do the y2 minus y1, x2 minus x1, you'll see you're going down to 6-to-1. All right, so that's that graph. Running out of ink. All right, so this one here, I'll just do it real quick. Asymptote at -3. That's what makes it 0, can't divide by 0. X-intercept at 2. End behavior, y equals 1. Y equals 1 on both sides. Put some numbers in to verify that. Sign changes. So I get sign changes. So over here, it's positive. Then it's negative. Then it's positive again. And I only have 1 x-intercept. So that's what the graph looks like. The limit as x approaches -3 does not exist because I'm going different directions. All right, just do this one. Hope the ink holds out. So -4, we've done a couple of these today. 5-to-1 ratio, 1-to-5 ratio change. All right, it's inverse of growth, so it's going to look like that. So I'm going to drop in what? -3. How far is -4 from -3? 1 unit. Log 1 is 0. We talked about that enough. That gets me 6. My next one's going to be 8. Provided, oh, that's the y value, excuse me. And that's going to happen when I make this number 5, which is 1. How far is 1 from -4? 5 units of change, because I saw that pretty quickly, and I hope you do too. And fortunately, that was captured by the camera because I never even looked if you could see what you were looking at. All right, I gotta stop. All right, okay, I can't do any more math today. Wrote 2 tests, 2 answer keys, printed them out, did a video earlier, did a video now, had 2 classes. I'm done. Bye-bye.